Welcome to Mac Studio YouTube channel. We may have heard the statement, drawing are the universal language of engineers. Drawing serves as the mode of communication for engineers to express and communicate ideas, dimensions, specification and technical information. That's why they are too important. Most of the engineering students are required to study engineering drawing or engineering graphics subject in their first year to learn about drawings. The concept of orthographic projection, specifically first and third angle projection, is fundamental and crucial for understanding the drawings. In this video, we will explore the concept of orthographic projection using animation. We have already studied the coordinate graph in schoolings, including the 4-quadrant graph. It consists of two coordinates, namely x and y coordinates. Let's see the brief explanation of the 4-quadrant graph. If the x value is positive and y value is positive, then it is first quadrant. Similarly, negative x and positive y represent the second quadrant. Negative x and negative y represent the third quadrant. Positive x and negative y represent the fourth quadrant. This construction of the 4-quadrant graph forms the basis for orthographic projections. In this context, the horizontal plane replaces the x coordinate and the vertical plane replaces the y coordinate. The horizontal plane and vertical plane are also referred as plane of projection. The position from which we observe the object is called as point of view or observer. In this video, this camera serves as the point of view or observer. First quadrant represents the region in front of VP and above HP. Second quadrant represents the region behind VP and above HP. Third quadrant represents the region behind VP and below HP. Fourth quadrant represents the region in front of VP and below HP. Now, let's consider this 3D object as an example for this video. Place this 3D object in the first, second, third and fourth quadrant. There is an important point to understand. For the first and fourth quadrant, the object is in between VP and point of view. For the second and third quadrant, the projection plane is between the object and the point of view. Also, there is a condition or assumption regarding projection planes. That is, horizontal plane can rotate only in clockwise direction. Now, let's add two auxiliary vertical planes. The plane on the left side is called the left auxiliary plane and the plane on the right side is called the right auxiliary plane. There are no conditions for auxiliary plane rotation. Orthographic projection is a method of representing the exact shape of the three-dimensional object on a two-dimensional sheet through two or more views. These views can include the top view, front view, left side view and right side view. Let's see the concept of first angle projection. Place the 3D object in the first quadrant. As mentioned earlier, the object is between the plane of projection and the point of view. Therefore, all the planes in the first angle projection are considered as solid or opaque planes. For better understanding, let's assume that we are using a light or lamp from a point of view position to produce light rays. These light rays provide us with a final image or the required view. Since the plane are opaque and the object is between the plane and observer, the light rays from the lamp passes across the object and falls onto the plane behind it. This produces the required view on the plane which is behind the object. So, the front view is produced on the VP. To obtain the left side view, move to the left side of the front view observer position and observe the object. Once again, imagine the light rays imagination. Now, the left side view is produced on the right auxiliary plane. To obtain the right side view, move to the right side of the front view observer position and observe the object. Again, imagine the light rays imagination. Now, the right side view is produced on the left auxiliary plane. To obtain the top view, move to the top side of the front view observer position and look down towards the object. This produces the top view on HP. As we know, orthographic view must be represented on a single 2D sheet and HP rotates only in clockwise direction. Therefore, rotate HP in clockwise, left auxiliary plane in clockwise and the right auxiliary plane in anti-clockwise direction. Thus, in first angle projection, the right side view is at the left end of the front view, left side view is at the right end of the front view and the top view is below the front view. Now, let's explore the concept of third angle projection. Place the 3D object in the third quadrant. As mentioned before, the projection plane is between the object and the point of view. Therefore, all the planes in the third angle projection are considered as transparent planes. Now, the light rays from the lamp or light source incident on the object and reflect back onto the plane in front of the object. Hence, the required view is produced on the plane in the front of the object, not behind it. This understanding is crucial. So, the front view is produced on VP. To obtain the left side view, move to the left side of the front view observer position and observe the object. Once again, imagine the light rays. Now, the left side view is produced on the left auxiliary plane. To obtain the right side view, move to the right side of the front view observer position and observe the object. Again, imagine the light rays. Now, the right side view is produced on the right auxiliary plane. To obtain the top view, move to the top side of the front view observer position and look down towards the object. This produces the top view on HP. rotate HP in clockwise, right auxiliary plane in clockwise, and left auxiliary plane in anti-clockwise direction. Thus, in third angle projection, the right side view is at the right end of the front view, left side view is at the left end of the front view, and top view is above the front view. Mostly, first and third angle projections are used, while second and fourth angle projections are not commonly used. The reason for this will become clear if you have properly followed this video until now. For example, let's consider second angle projection. In this case, the projection plane is between the object and the observer, and the plane is transparent. As a result, front view is produced on VP and top view is produced on HP. When HP is rotated clockwise, the top view and front view overlap each other. That's why it is not used. The same principle applies to the fourth angle projection, where the front view and top view overlap each other. Symbols for first and third angle projection. Here, truncator or frustum of cone is the 3D object, and its front view and side view or top view are represented as a symbol. A frustum of cone is a part of the cone obtained when it is cut by a plane into two parts. The reason for using a frustum of cone is that it is a simple 3D object with different side views. Although a cube, rectangular bar, and a cylinder are simple 3D objects, but their side views are similar. You can easily understand the projection symbol using the concept of first and third angle projection. These two symbols are commonly used, but it is important to note that they are not the only symbols used for the projections. Avoid assuming that if a double circle is on the left side of the truncated cone, it represents third angle projection, and if it is on the right side, it represents the first angle projection. This assumption is not always correct. These four symbols represent the first angle projection, and these four symbols represent the third angle projection. A simple trick exclusively for our viewers is that in first angle projection symbol, the cone is always angled away from the circle. In third angle projection symbol, the cone is always angled towards the circle. The top view is also known as the plan, the front view is also known as the elevation, and the side view is also known as the end view. First angle projection is mostly used in India, Canada, and European countries, while third angle projection are primarily used in United States and Australia.